In this lecture, we're going to learn how to use dimensional analysis to convert from one unit to another. So the first thing we need to talk about are the metric unit conversion factors. Scientists, whether they be chemists, physicists, biologists, have these conversion factors memorized. So if not for this class, for life, for your next science class, you need to know these ones right here. It's not as bad as it seems. So how this works, the metric system goes by factors of 10. And we have what's known as our base units. So for base units, say you're trying to measure mass. In the metric system, you're going to use grams to measure mass. And that's abbreviated with a lowercase g. So that's what's known as your base unit. You can make grams bigger by adding a prefix in front like kilo, or you can make grams a smaller unit by adding centi or milli in front of the grams. Of course, you're going to want to measure a lot more than mass. You might want to measure distance or length. For distance, we're going to use meters. And that's going to be symbolized by lowercase m. You might want to measure volume. In the metric system, you'll use liters to measure volume, and that's going to be a capital L. Some other ones, time. In the metric system, it's going to be seconds. And the abbreviation for that is just S. You can do energy. So energy is measured in what's known as joules. And that's going to be a capital J. And the last one I'm going to just write down, we're going to talk about it more later, is known as a mole. And it's a counting unit like a dozen, and it's abbreviated MOL. But you can use these same metric system prefixes in front of the mole. So it's pretty common to have a micromole or a millimole, just to be aware that these prefixes pretty much work in front of anything. Let's talk about how these prefixes work. So I'm going to use the example of a meter to set up all of my conversion factors. A meter is about 3 feet. A lot of classrooms have meter sticks, so you can kind of visualize what a meter looks like. Maybe you're measuring a long distance. You're measuring the amount of distance between Los Angeles and San Diego. You're not going to want to measure that in meters because that would be a super big number. So you're going to use kilometers instead. Maybe though, however, you need to convert it to meters for whatever reasons. So there's this conversion factor. We can say that there's 1,000 meters in 1 kilometer. Or we could say, so conversion factors can always be flipped upside down. I kind of think of them like dominoes. Like I'm just going to flip the piece to make it work for me. So I can say 1 kilometer has 1,000 meters. Even bigger than that, and I made note of that over here, these two prefixes are going to make your new unit larger than the base unit. So even bigger than that is a megameter. So there's 1,000,000 meters in 1 megameter. We can also flip that, and to save some space, I'm going to use scientific notation. So I could say 1 megameter has 1 times 10 to the 6th meters in it. All right, so those are larger. We also have a whole bunch of conversion factors that are smaller than our base unit. So, and again, you have to memorize them. So whatever works for you. With mega, I always think of like mega millions, like it's the lottery. I'm going to win $1 million. Over here, I like that these come from Latin roots, or if you speak Spanish, you see the Latin roots in there as well. So like diez, cien, un mil, because in Spanish, mil means 1,000. Some people are like, well, it reminds me of decades, century, millennium. For a decimeter, we can say 1 meter has 10 decimeters, or there's 10 decimeters in 1 meter. For centimeters, right? They're pretty small. There's 100 centimeters in 1 meter, or 1 meter has 100 centimeters. Continuing along those lines, we have millimeters. So when you look at the meter stick, the little lines on a meter stick or on a ruler, those are your millimeters. There's 1,000 of those little millimeter markings in the meter stick. So 1,000 millimeters in 1 meter. Or we can say 1 meter, again, these can always be flipped, has 1,000 millimeters. I'm going to finish this one up, and then I want to talk about this. So hold on, let's just finish the pattern here. Micro gets even smaller. So we have 1 million, or 1 times 10 to the 6 micro. The symbol kind of looks like letter U, so micrometers. It's not a U, but it looks like one. In 1 meter, or 1 meter has 1 million micrometers. And the last one, nano. So because the atom's so small, we measure things in nanometers, like the distance between 2 atoms, for instance, in a bond. And it's 1 times 10 to the 9th. So there's 1 times 10 to the 9th nanometers in 1 meter. 1 meter has 1 times 10 to the 9th nanometers. Okay, so at this point, students get a little bit upset at me and they say, well, what is this gibberish? Why did you write 1 times 10 to the 9th when it clearly says 1 times 10 to the negative 9th? So where that comes from is every single textbook. Every single textbook has it written like this, and I hate it. It never worked for me as a student. It confused me as a student. So I decided to teach it differently than textbooks teach it. So if you wanted to use it in this form, you would have to write, and I wouldn't write this down on your paper. I just want to show you what this number means. You'd use 1 times 10 to the negative 9 meters in 1 nanometer. So basically you would have to split the meter up into a billion pieces. To me, that's counterintuitive. I don't want to split a meter into 100 pieces and think about it that way. I'd rather think about the fact, which most of us have known our whole lives, that there's 100 centimeters in 1 meter. I don't want to think about it the other way. So just ignore this. It's kind of there just, if you've seen it before or you run across it, that you don't let it bother you too much. So for my way, you're always going to think about, is it larger than the base unit or smaller than the base unit? And then in addition, you're always going to place the 1 when you write your conversion factor in front of the larger unit. So a kilometer is bigger than a meter. A kilometer is like a mile. So I'm going to say 1 kilometer contains 1,000 meters. Down here, a meter, I wrote 1 meter. I put the 1 with the meter because it's bigger than a millimeter. Alrighty, so how are you going to memorize all of this? So there's 1, 2, 3, 4, 5, 6, 7. You're going to need 7 flashcards. And you're going to write 1 million meters in 1 megameter on your first flashcard. And then you're going to circle the lowercase m's. And the reason why you're doing that is because the lowercase m's stand for meters. But they can be interchanged or substituted out for any of the other base units. So you can say that there's 1 million grams and put a G here where I circled in 1 megagram. Over here, you could do 1,000 liters in 1 kiloliter and put capital L's. You can substitute out any base units for the M's in all our setups here. And so I circled all of the lowercase m's in red, and I encourage you to do the same on your flashcards. Also, I know that you can sit there and have these notes available when you take your quizzes, but you're gonna have to have this memorized for all of your science courses. So I highly, highly encourage you to memorize this. It's just basic knowledge when it comes to science. So here I am encouraging everyone to circle the lowercase m's, and I know the double M has always been a point of confusion for some students. So just as a reminder, when you see 2 abbreviations in a row and it's part of the metric system, the first abbreviation, so the first letter, the lowercase m, this is going to be your prefix, and this stands for milli. Then your second letter, the second M, is going to be your base unit, and that stands for meters. So you're going to be substituting out that second M or the base unit. Alrighty, so when you're writing your conversion factors, you're going to find the metric system conversion factor in meters from the list above and substitute out the appropriate base unit. So I know that a kilogram or kilo is bigger than the base unit. So I'm going to do 1 kilogram has 1,000 grams. Or there's 1,000 grams in 1 kilogram. So it's the same thing that we wrote above, except instead of the letter M, now I'm using the G's for grams. This would be millisecond. So which one is bigger, second or millisecond? So second's bigger. So I'm going to say there's 1,000 milliseconds in 1 second. And 1 second contains 1,000 milliseconds. For the rest of them, mega is bigger than seconds. So 1 megasecond has 1,000,000 seconds. There's 1,000,000 seconds in 1 megasecond. Between liters and microliters, liters is bigger. So 1 liter has 1,000,000 microliters. There's 1,000,000 microliters in 1 liter. Kilojoules and joules. Kilo is always bigger, right? So 1 kilojoule has 1,000 joules, and there's 1,000 joules in 1 kilojoule. For centimeters to inches, they're both measurements of distance. This happens to be an exact number. So there's 2.54 centimeters in 1 inch. And if you recall from our discussion of exact numbers, then this conversion factor is not going to have an impact or shouldn't be considered when you're trying to figure out how many sig figs your final answer has. Also, all of the metric conversion factors that we just went over are also exact numbers. Pounds, so that's the abbreviation for pounds, LB, pounds to kilograms. And so we'll say 1 kilogram has 2.205 pounds. So we can flip that and state that there's 2.205 pounds in 1 kilogram. Liters to quarts. So 1 liter has 1.057 quarts. 1.057 quarts in 1 liter. They're both measurements of volume. Kilometers to miles is an important one, right? 1 mile has 1.609 kilometers. So this means that a kilometer is much smaller than a mile. And so when you're driving in foreign countries, Mexico, Canada, Europe, they're all going to use kilometers. So remember that the kilometers are smaller than a mile. 1.609 kilometers in 1 mile. This next one, milliliters to centimeters cubed to cubic centimeters. If you ever watch those hospital shows and they're like, we need 400 cc's of blood, stat. What are they talking about? Well, they're talking about a milliliter. All these things are equivalent to one another. So 1 milliliter is equal to 1 centimeters cubed, which is equal to 1 cubic centimeter. You do have to know that one. You do have to memorize that one. And like all the other metric system stuff, it's an exact number. Moving on. This ATM stands for atmospheres, and mmHg stands for millimeters, and this is mercury. It's from the periodic table, so it's millimeters of mercury. And what you're looking at here, this is a pressure unit. So if you're trying to figure out how much pressure is in a balloon or in a cylinder, like a gas tank or something like that. 1 atmosphere has 760 millimeters of mercury. That's the conversion factor there. And you could also flip it. Ounces to grams. OZ is for ounce. We can say 1 ounce has 28.35 grams, or 28.35 grams in 1 ounce. Meters to yards. A lot of times if you have a meter stick, if you flip it over, there's yards on the other side because they're so similar. 1 meter is 1.094 yards, or you could say there's 1.094 yards in 1 meter. Joules. I mentioned that this is a unit of energy. This is calories. So if you ever read food labels, right? They say calories, it's actually kilocalories on the food label, but they're both units of energy is what you need to know. So 1 calorie has 4.184 joules, or we can say there's 4.184 joules in 1 calorie. And again, have these, reference them. Don't memorize them except for the milliliters, centimeters cubed, cubic centimeters one.